Hey guys, this is LegoMass99 today, or Duncan, and today we are going to program the multiplying program that is shown in the demo video of this computer into this computer. I'll show you guys how to program it, how it works and everything, and this video is going to be an extension of the programming tutorial mini-series videos thing that I'm doing to show you how to program this computer. So without any further ado, let's go ahead and jump right to it. For this program, I'm going to be programming this on Core 3, which is right here in the program memory. And I have already cleared the program memory for writing new instructions, which is good. That saves us a little bit of time. And I'm going to be programming it here on Core 3 so that we will be able to, get experience with programming with Core 3. And then if you guys haven't noticed, I'm going to be programming one program on each core so that you guys will be able to see how it all works. So the multiplication program that I'm going to be using to program with this is in the doc that is provided with the world download in the official video description. Pretty much at the bottom of the doc where it says multiplying program, takes two 4-bit numbers from the user and multiplies them. And that is pretty much what this program is going to do. So let's go ahead and get started. Alright, so the first line of code that this program requires is acquiring number 1 counter, and before I actually start programming this program, is the first program that I've shown you guys that deals with user input. So if you guys want to learn how to use the user input, then this would be the program for you. So anyway, we are going to turn on computer indicator 1. So to do that, we are going to go ahead and issue an IO output command, which is ID 9, I think. So we'll do 1 and 8. And if you're ever unsure, check the doc or the decoder. 1, 2, 3, 4, 5, 6, 7, 8, 9. IO output. Okay. And now for the operations ID, we're going to go ahead and sorry, my voice is starting to die a little bit, but I'm going to go ahead and look at the doc here. Let's see. All right, so I think 4 is the ID for computer indicator. Oh, that's not 4. This is 4. For computer indicator 1. And then for computer indicator 2, it'll be 5, 3 is 6, then 4 is 7. If I remember properly, and I'm looking at the doc here, so that should be accurate. So that's line 1 of code. And then, as usual, we'll be doing the instructions first and then the go-to. So for line 2 of code, we will that will be a conditional statement. So we're going to go ahead and leave this blanks, and this will be entirely dedicated to checking if the user has input something or not. So line 3 of code, you're going to go ahead and input the user input and then write input to RAM address 1. So this pretty much works the same way as the add command does, and in the fact that once you specify the opcode here, you are able to manipulate that data from the IO input from whatever source you input from. So if we issue an IO input opcode command and we select user input, that user input data will be available to us. And now this is where it gets different for this instruction only. And after that, that data will not be available to us until we issue another IO input command, and then we'll have that data available, and so on and so forth. So I think IO input is actually ID 10, if I remember right. I'm not too sure. Oh, that's not 10. It's 2 and 8. 2, 8. Let's see here. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. That's right. So IO input, and then I think operations ID number 1 is user input. Let's go ahead and I'm going to check the doc here. Let's see. Yeah, so 1 is user input for the IO input command. And now that we have that data available to us, theoretically, we're going to go ahead and write to RAM address 1, which I think is the cyan, actually. So it's flipped on this side. So actually, let me check the doc here. Yeah, cyan is right. And so on this particular core and core 4, in the program memory, it's switched around. So that's why I'm showing you guys how to program on each course, because they are a little bit different. Oops, I bumped my mic there. Sorry about that. But anyway, we are writing to RAM address 1 in this command. Now on the next command here, we are going to go ahead and turn on computer indicator 2. Now this is going to be the data. So basically, the way this program works is that the first user input collected, so let's say we wanted to do 5 times 5, since multiplication is repeated addition, we collect two pieces of data. The first, which is A, and then second is B, so A times B. And so A acts as a counter, and then B is the actual data. So if we wanted to do 5 times 5, it would add B, which is 5 times over until it got 25. That's how this program will work. So let's see here. All right, so we're on line 4 of code. So we're going to go ahead and turn on computer indicator 2. So we want IO output, which is opcode 9. And then I think is actually operations ID 5. So we're going to go 4 and 1 for computer indicator 2. And then that's all that for that command. And then for line 5, that is also another purely conditional command here, so no instruction on here. Line 6, IO input, user input, and then we'll write that input to RAM address 2. So operations ID 10, no, not operations, so operations ID 1, opcode 10 for user input. And then, let's see here, we're going to write to RAM address 2 this time, and I think this is 2. Let's go ahead and check. Always make sure to check your bit values, especially on this computer since they change and they're kind of wonky a little bit. All right, and then they're going to go ahead and write 1 to RAM address 4 on the next line of code here. So we're going to go ahead and write to RAM address 4, and then I think this is 1, I'm not too sure. This is 128. Okay, a little bit off from 1, so 1 should be all the way over here. All right. So, okay, so this is writing 1 to RAM address 4, and I think this is basically checking if it is, okay, let me read the code here a little bit. Okay, so this is basically like a constant, so when we subtract the counter, we just subtract it by this RAM address. All right, so that was the initialization part. If you notice in the doc, it says initialization. And now for the main loop, the first line of code here is that we're going to compare RAM address 1 and RAM address 6, which is a, as it says in the doc, a 0 value placeholder. So it's basically checking if our counter is 0, which means we are finished. So to issue a compare command, I think it is actually 3. Oops, go make sure to replace that, because that will be a slight problem if that was not fixed. All right, so I think it is actually command 3. Yes, ALU compare. And the way, and the way this works is that you go ahead and it's basically it works the same way like the ALU add and ALU subtract numbers, where you have to specify 2 numbers for it to do anything. So we're going to go ahead and enable dual read mode, which I'm just going to guess which one it is, and I think it is okay. So let's go ahead and check down here. I think it is this one. It is this one. Okay. So it's bit 2 on, oh wait. Yeah, it's bit 2 on the RAM modifier bus thing. I forgot what it's called. We'll just say the blue bus here. And so we're going to go ahead and compare that, and let's go back a little bit here. All right. And now we're going to go ahead and read from RAM address 1, and I think RAM read is cache A. So this will be the first number compared. So RAM address 1, and then RAM address 6, which again is a 0 value placeholder. And now we have to make sure we get this order correct, because, or in this particular compare instance, we're just going to be checking if they equal each other. But in other commands, if these are flipped, then you might get different answers, because like this computer can check if it's greater than or less than. So it might, if you flip them around in the way you want it to, you might get a different answer. All right, so for line 9, we are going to subtract RAM address 1 from RAM address 4. So ALU subtract is line of opcode 2. Enable dual read mode again, and now so subtract RAM address 1 from RAM address 4. And now a very important note to note, let me see here in the notes. Okay. A very important note to note about the subtract command is that the way you input the numbers, so the way you read them, is very important. So actually cache A, so the first number is on the RAM right, according to the doc here. Yeah. Okay. So the read A is the blue, and then the read B is the cyan. All right. So we'll go ahead and test that anyway, but we're going to go ahead and subtract 1. So I'm going to go ahead and go 1 and 4. And that's the whole thing about debugging. But since if it's wrong, then I'll go ahead and fix that. And I have a feeling that might be wrong, but we'll leave it like that for now. Let's go back to our program here. All right, so that's subtracting that. And then on line 10, we will write the output to RAM address 1. So we don't need any opcode here. We'll just write to RAM address 1. And we are able to do this because we still have the data available in the core output register from the subtract command here. All right, line 11. Flush output register, and I think that is opcode. I'm not too sure. I think it's 7 actually, if I remember right. And then I do remember the operation ID is 1. Let's go ahead and check the decoder here. 1, 2, 3, 4, 5, 6. Yeah, 7. Okay. So now we are flushing the core output register to remove that data. And then line 12, we will add RAM address 2 to RAM address 3. So ALU add, dual read, and then RAM address 2 and RAM address 3. That's right. And then, all right, so that'll be that. And as you can see, our program is actually kind of big, or since we don't have that much program memory here. All right. Line 13, write output to RAM 3. So we'll go ahead and write an output like that. All right, there we go. And then line 14, flush output register again. So opcode 7, and then operations ID 1. And then 14 goes to line 8. And then, let's see here. For line 15, we're going to go ahead and read RAM address 3 and output the decimal display. So output is 9, I think. And then decimal display is opcode 1. I'm pretty sure. And then we're going to read RAM address 3. So read 3. And then line 16, turn on computer indicator 3. So IO output. And then this is opcode 6, I am pretty sure. And let's see here. Line 17, shut down the computer. So that is 11, 2, and 8. And then line 18 here, turn on computer indicator 4. So that is IO output. And then just 7 for operations ID. And then 18 goes back to 17. So the way the program will work here, the program flow, is that it'll go through the first 7 lines of code. So 1, 2, 3, 4, 5, 6, 7, and then on the 8th line of code, it'll loop. So basically, 8 will check if it's equal to 0 here. And then if it is, it'll jump to line 15, which is outputting to the decimal display. Wait, no, I think this is it right here. Yeah, line 15, we're going to output the decimal display, and then turn on computer indicator 3, which means that it has executed successfully, and then shut down. But, all right, so that's that. And then on line 8, if not, then it'll continue. And let's see here. And then on the add command, line of code 12, so 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. No, I didn't do that adding. Okay, I guess I did. On line of code 12, it will check for a shift overflow. And if it has shift overflow, then it will go ahead and jump to line 18 here, which basically it'll turn on computer indicator 4, which means the program has exited with an error, with a shift overflow error, and then it'll jump to here and then shut down. And then, yeah, that is pretty much the program flow. And then on line of code 14, which is a flush output register, it'll jump back to line of code 8. So it'll loop, and then once it hits either the counter equaling 0, which means the multiplying is complete, the repeated addition, or if we hit a shift overflow with the add, it'll jump outside of the loop and then shut down the computer either way. So that is those are our instructions. pretty much program it into this computer, and now we will go ahead and program the goto branches into the computer. Alright, so for line 1 of code, we will go ahead and go to line 2, and I think, okay, so magenta is false. So whenever you want to go to a line of code unconditionally, so always, put it in the magenta here, since if there's no condition, the condition status is always false. Alright, so line 2, and then line 2 we go to, alright, so now we have just a pure conditional branch here. So if computer input 1 is enabled, if it's not enabled, then jump back to 1, so that'll be false, jump back to 1, and then if it is, jump to 3, and our condition here for computer input 1 enabled is, let's take a look here, where is it? Here they are, 1, 2, 3, 4, 5, 6, I think. Let me do that again. 1, 2, 3, 4, 5, 6. Okay, so it is computer input 1 is 6, and line 2 here. Let's see, make sure you got the bit values right, 2 and 3. So now this will check if we have, if we go up here, if we have flipped the switch, right here, computer input 1, if we flip the switch, and then we'll check for that, and then if it is, it'll continue, if not, it'll jump back to the beginning of the program. And when we flip this switch, we are indicating to the computer that we have a number here. And then that is that. So on line 3 of code, so that is our quote-unquote if statement, or conditional branch, I'd like to call it. And then on line 3, you will go to line 4 unconditionally. And then on line 4, we will go ahead and go to line 5, so 4 and 1. And then on line 5, we have another one of those purely conditional statements. And then if the computer input 1 is enabled, then jump to 4. If it's not enabled, jump to 4. And then if it is enabled, jump to 6. And that's basically checking again if the second number has been put in, then it's the same condition test ID, which is 6. So basically the way we'll input numbers is that the computer will turn on, computer indicator 1 here will turn on, and then I'll go ahead and sleep the computer, and then go ahead and input our number, flip this switch, and then run the computer again. And then if it's taken the number in, computer indicator 2 will turn on, and then we'll sleep the computer again, and then input our second number, and then resume the computer. So, alright, and then the computer will have our 2 inputs in. So 1, 2, 3, 4, line 6 of code here, we will go ahead and go to line 7, so 7. And then line 7, we'll go to line 8. And then line 8 here, we will go to, alright, so now we have, should be our compare command. Yep, so this is compare. And now we are going to go ahead and test for equaling, for A equals B. So let's first put our destinations in here. So if RAM address 1 equals RAM address 6, then jump to RAM 15. So if it's true, we'll go ahead and go to 15. Then if it's not, you'll go to 9. So, oops, 1 and 8. Alright, and now I think the ID here is, alright, 1, 2, 3. So it is condition test ID 3. And let's see, here it is. So then we'll go with 3. So this will basically check if A equals B, which in this case, if RAM 1 equals RAM 6, which basically means if RAM 1 equals 0. And let's see here. Alright, so line 9 of code, we will go to line 10, so that's 8 and 2. Then line 10, we will go to line 11, and then line 11 to line 12, so then 4 and 8. And then line 12, we have another conditional branch here. Oh, this is 12, right? 12, 13, 14, 15, 16, 17, 18. Okay, yeah, it is 12, okay. Alright, I thought I counted something wrong. So on line 12, we're going to go ahead and test for a shift overflow. So that is by default condition test ID 1, and this isn't our add command. And so if we hit a shift overflow, we go to line 18. I think, yep. And then if it's false, then we jump to line 13. So then that is 11. Okay, so 8, 12, 13. All right. Now on line 13, we're going to go to line 14, which is this, I think. 8, 12, 14. Yep. And then 14 back to line 8. And like that. All right. So now line 15 here, we are going to go to line 16. And then 16 to 17. And then that is that. And then on line 18 here, so 17 doesn't need anything because it's not going anywhere else because this is the shutdown command, or it should be. Yep, okay, it is. So we'll leave that blank, and now on line 18, we're going to go back to line 17. And then that should be our code complete. So that is the multiplication program programmed into core 3 of our computer. And now we will go ahead and debug our program. Alright, so we're going to go ahead and debug our program. So first, we need to enable core 3, which is a very important step. And now I think that is all we need. Yep, okay. So let's go ahead and go to the debugger center. And we will go ahead and load the first line of code into our computer. I'm going to go ahead and bring up our F3 screen here, and then I'll copy our wirelessly implementing line of code command into my clipboard. Alright. So now as you can see, line 1 is going to be loaded next. Oh boy, that lag. Sorry for that lag. Oh, the lag is real. Oh my goodness. I'm sorry. But anyway, this is going to be line 1 of code, so we're going to load that in. And now that should be turning on computer indicator number 1. And the lag is truly real. And as you can see here on the program output panel, computer indicator 1 is on, which is good. So now we will go ahead and load our next line of code in. And alright, so now we have line 2 of code loaded in, and as you can see, it's going back to line 1 of code here as indicated by this redstone being powered off. And the reason for that is because computer input 1 enabled is false, which is, as you can see, it's not flipped, so we are jumping back to line 1 as we wanted to, which is good. And since we have the program in a pretty frozen state like this, if we turn this on, we should jump to line 3. Yeah, as you can see, now the computer is going to jump to line 3, which is good. And let's see here. So let's do a simple calculation of 2 times 2. So we're going to put a 2 in there. So now this is indicating that we have a value here and that we're ready to input it. And then if, let's say I unflip this, and then we go ahead and load our next line of code, it will basically just turn that light on again. So this light will blink until the computer has detected that we've flipped that switch, which means that it has a value. And so when we clock next line of code, we go to line of code 3, and now we will load line of code 3, which is taking the user input from the user input here and writing it to RAM address 1. So we'll go ahead and fly over to the RAM here, and alright, so as you can see, we have our 2 coming in, and then it's being written to RAM address 1, which is very good. And now we'll go ahead and load the next line of code in, and the computer can get pretty laggy and slow when we're debugging like this. So, and then as you can see, we have our things up here. Now we are in line 4 of code. We have computer indicator 2 on, and I'm just going to leave this on since we are doing 2 times 2. And let's see here. Alright, so computer indicator 2 is turning on, which is good. And now you'll go ahead and load the next line of code, which is, it should be, alright, as you can see, it jumped. It should have gone to line 6, yep. Oh no, we are on line 5 right now, so we are doing the conditional test. And as you can see, it is jumping to line 6. You'll go ahead and load line 6 of code. And we should be writing 2 to RAM address 2 now. So let's go ahead and fly over here, and as you can see, 2 to RAM address 2, which is very good. Working the way we want it to so far. And now we will go ahead and write one to RAM address 4. Now just wait here for that. And as you can see, RAM address 4, we are writing a 1. That is good, it's working. Alright, next line of code. We are going to compare RAM address 1 and RAM address 6. And let's see here. You'll see what line of code it wants to go to. So it wants to go to line of code. As you saw 15 there for a second, and now it's going to line of code 9. And the reason for that is because it took a while for it to load into the ALU and then do that calculation. So it looks like we've programmed our compare command correctly because it wants to go to line of code 9, which means they are not equal to each other, which is good. So now we'll go to line of code 9, and now we are subtracting RAM address 1 from RAM address 4, and as you can see here, oh, okay, all right. So we had a shift overflow for a second, and it looks like that's been resolved. And a subtractor will do that occasionally. And I think core 3 is actually down here. All right, yes. So core 3 is actually down here, and as you can see, 2 minus 1 is indeed 1. We're getting that output from the core 3 output register, which is very good. It's working the way we want it to. And now you'll go ahead and write that output to RAM 1. So we are updating that counter to be 1, so that we have basically added 2 one time. And that is working, which is great. Now we're going to flush the output register, so this signal here should disappear. Yep, okay, good. Now we are going to add RAM address 2 to RAM address 3. So right now it's 2 plus 0, and that should give us 2. And it does. Oh, wait. Okay, let's see here. 2 plus 0 is 2. Let's go ahead and check the core output register. Yep, we are getting a 2. Great. And actually, we should be jumping to line of code 13 because we have not hit a shift overflow. All right, we are. It's good. And that's why these here are useful, so you don't have to go down and actually count the lines of code and such. Oh boy, I had a frame dip there. Okay, so line of code 13, we are writing that output to RAM 3, which is our output address. So we are writing 2 to RAM 3, which is good. And now we are flushing the output register again. And okay. So yeah, as you see, it's gone. And now, let's see here. RAM address 3. And then now we should be going back to line 8. So if we look at our line of code indicators here, all right, as you can see, the computer is going to jump to line 8, which is good. And that's basically the very top of the main loop again. And as you can see, it hit 15 because the data is still being loaded into the ALU. And as you can see, now it's turned off, which is good. So basically, we're going to line 9 again since 1 does not equal 0, working as intended. And we will subtract RAM address 1 from RAM address 4. And then if the shift overflow light blinks, then that is alright, but if it's solid, then you have an actual shift overflow. Since I think the second value loads before the first, and then it gives a negative value just for a second. And now, as you can see, we have 0 because we subtracted 1 from 1. Alright, so now, next line of code 10. We will write that output to RAM 1. So let's go ahead and look at RAM 1. We should be writing a 0. And good, we are writing a 0. And now we will flush the output register, which has nothing in it, so we can go ahead and load the next line of code. Now we are going to be adding RAM 2 and 3, so then that'll be 2 plus 2 now, and that should be 4. Let's go ahead and take a look at the core output register. Alright, it is 4, which is great. And this means working properly. So it looks like most of our program is working here, which is good. Most times when you're debugging, it won't always work the first time, but I've tested most of these programs, so they should work fine. The only way I'll probably mess this up is if I program it in wrong. So it's going to line of code 13. Now we're going to write output to RAM 3. And we are writing a 4 to RAM 3, which is our output address, as I said before, which is working. Now we will flush the output register. And there we go. Okay. And now, let's see. That is flush. Now we're going to line 8 again. Now, as you can see, this should stay solid. This should not change because 0 does equal 0. So we'll give it a little bit of time here. And I will go ahead and check the condition register. Or not condition register. Well, yeah, condition register. Let's see, where is it? It's right down here. Condition flag. So, as you can see here, A equals B. So that, and then we're going to jump to line 15, which means that the operation is complete. And if you recall, the value that we currently have stored in our output address is 4, which is the correct answer. So we're going to line 15. As you can see, loading line 16. We will read output from RAM 3 and output it to decimal display. If we give it a second, there's our 4. Now line 16 will turn on indicator 3, which it does. And now should go to 17, and that should shut down the computer. So if we go ahead and do that, we'll just watch this. That should turn off, and then everything should shut down. All right. So it looks like it's shut down. Hopefully, let's see if our RAM's clear. I don't think the RAM clears though when we're testing it. Yeah, it doesn't clear. Okay, that's right. But then this is on, which basically means that the shutdown is on. Since when we shut down the computer, we reset all of the registers in the computer except the memory. All right, so our program here has pretty much been successfully debugged, and it mostly works. So now we are going to go ahead and run it automatically with the clock and test it like that. And we will go ahead and do that now. Alright, so for the sake of simplicity, I'm just going to go ahead and use simpler numbers here. So I'm going to have this always on. And let's see, for inputs here we will do, why don't we do 5 times 5. So we'll go 5, and then if we just leave this on, it'll input 2 5s. And let's see, we'll have core 3 on. And I'm going to go ahead and run this at a safe speed of 90 ticks. And then we will turn this off so that when the computer shuts down, we will see our value here. And report program exceptions to I/O. And now I'm going to go ahead and start the program, and I will probably time-lapse it. So there's our computer on. It's not turning on. All right. We have a problem here. Let's fix that problem real quick. Alright, Alright, so I have found the problem. It looks like that the shutdown command is still running from our debug test, so you will go ahead and go over here and then reset the instruction registers. And then you'll go ahead and run a computer shutdown. And I think that should clear everything. Let's go ahead and wait for our chunk updates to go down a little bit. Alright, there we go. And now we should not be forcefully shutting down it anymore. Alright, we are not. That's good. So, something very important there. When you issue a shutdown command and you're finished debugging your computer, or your program, make sure that you reset the instruction registers and shut down the computer again from the debuggers panel. So that'll be very important. So now I am going to go ahead and turn on the computer. Alright, so now we are on, and I'm going to go ahead and time-lapse the program, since we will go ahead and I'll just let the output stay here. We will go ahead and time-lapse this. So I will meet you guys back at the end of all of this, when the answer is printed on the screen or when something else happens. Alright guys, so our program here is just with a shutdown, and I think it is going to shut down. Okay, so adjusted, shutdown, and as you can see, we have 25. And that has come out, which is correct, which means the program worked successfully and it worked. Just to have lack of a better word for it. So I'm going to go ahead and clear that. So I'm just going to press off again. So that's how you clear all the displays and RAM and everything. You just flip that switch and then press the off button. And as you can see, now it's all clear. And that is pretty much programming the multiplication program in this computer. If you guys have any questions or any other programming requests for this computer, please let me know. Thanks for watching, guys, and until next time, see you later. Bye-bye.